to enable the launch. This mobile gantry hosts other facilities which enable the integration of the stages, crane, platforms, the system used to check of other stages and to fuel the last stage.
All right, staying with Astrium builders of VNREDSat-1, our next film, an interview with their CEO, Eric Béranger.
We are extremely proud that Astrium is building the first Vietnamese Earth observation satellite, VNREDSat-1. With this satellite, Vietnam will join the exclusive club of satellite owners. Let me finally thank all partners involved. VAST, our Vietnamese customer, who entrusted us with building their first satellite. Not to forget, under the leading and determined vision of Professor Min. The French authorities for their close involvement in the building and nurturing of the cooperation, and for their help at key points of the program. Arianespace, ESA, and CNES for their support and professional service for launching the satellite. And of course, the Astrium Satellite project team and the Astrium Satellite suppliers for their excellent work.
Let's talk about who does what in the Vega program. Shall we start with ESA?
Yes, ESA was responsible for the implementation of the program and of its technical and financial management. As is, the Italian Space Agency provides 50% of the funding and also has a large management role. CNES, the French Space Agency, led the project team for the P-80 stage development and was involved in the combined test campaign.
Arianespace, as with Ariane and Soyuz, holds exclusive rights to operation, marketing, and sales of the Vega launch services, also supervises integration and inspection of the launcher that's built by ELV, the prime contractor.
Yes, ELV holds industrial architect responsibilities and is the industrial prime contractor. Avio is the program primary industrial partner, and Vitrochisat is the prime contractor for the ground segment.
Over to Mart Norman now, the mission director for ESTCube-1, for a look at the first Estonian satellite.
ESTCube-1 is a one-unit cube satellite which mission is to demonstrate advanced centrifugal tether deployment on low Earth orbit. This is the first step towards development of a novel spacecraft propulsion system for space debris mitigation and interplanetary space flight called the electric solar wind sail. In addition to its scientific mission, ESTCube-1 is mainly an educational program. It is developed by the students from Estonia and 6 other countries in cooperation with Estonian, German and Finnish space research institutes, led by the Tartu Observatory and the University of Tartu. Since the start of the project in 2008, almost 100 students have contributed to the project. Our team is very happy that we have the opportunity to launch our satellite on board of the new Vega launcher. This is a part of the cooperation between Estonia and the European Space Agency. Estonia has currently the status of the European cooperating state with ESA, and we hope to become the ESA full members in the near future. Estonia contributes already to many ESA activities through the PEX program, and our young engineers from the ESTCube-1 project definitely hope to contribute to the ESA peak satellite missions in the future. At the same time, the student satellite program will continue to be the flagship initiative for science popularization and engineering education in Estonia. Thank you.
Enrico, he mentioned ESA's PEX program. What do you know about that?
Yes, the PEX is a program for European cooperating states. For European Union members who are not yet ESA members, a cooperation program giving them a way into ESA, a sort of a bridge, you know. They can learn to deal with ESA and show ESA what they can do. It's a political decision to join ESA, and so many countries for Eastern Europe have gone this way. Czech republics and most new European Union members.
CubeSats on the first Vega flight were built also by university students in Italy, Romania, Hungary, Poland, France, and Spain. ESA has a comprehensive educational program which encourages such projects. A look now at Vega's commercial future with Louis Laurent and Jacques Breton of Arianespace.
From the operational point of view, the organization which we have set up for this demonstration launch constitutes a transition between what was done during development and what we shall be using during the operation of Vega. The organization is based on a few key principles. The first is a breakdown of functions between the stakeholders in line with what we habitually practice with Ariane and Soyuz and which has been very effective over the years. The second is the use, when necessary, of the expertise developed in the Italian industry to process specific issues. And the third is to maximize synergies between the operations of Ariane and Soyuz in order to benefit from the experience of methods which have been developed over the years on these launches. Going forward, we have three key working developments. The first is to leverage this launch to draw every lesson that we can, what we have learned during the campaign and the launch. The second is to move from a one-by-one operating production to a series production, what is known as the industrialization phase, which is a classic approach in our business, consisting in improving quality, reducing campaign length, and reducing operating costs for Vega. The third is to increase the rate, to ramp up. The prospects of Vega's market are excellent, and we wish in the short term to ramp up to 3 launches per annum, which will require a certain number of investments. And we shall be working, as of tomorrow, in this direction.
With the second launch of Vega today, Arianespace, ESA and the industry demonstrates that the Vega launch system is available and reliable. In 2011, we signed the first contracts for launches on Vega for Sentinel-2B and 3B. Last year, we signed the first export contract for DZZ of Kazakhstan, a satellite built by Astrium. And I expect that this year, after this successful launch, we will positively conclude some discussions going on in the Mediterranean area in particular. So I expect some announcements to be made in the coming weeks. Stay tuned. Vega is a perfect launch system for small missions, for Earth observation, scientific missions, technology demonstration, a perfect way for countries wishing to enter the space world to launch their first mission. There is a potential for Vega. We have now to turn it into a commercial success, as we did with Soyuz and Ariane 5. In that respect, this year, 2013, has already been a success, as we have already signed and announced 7 launch service contracts for satellites to be launched by Ariane 5.
The launcher Vega will have a big future in the small satellite market. In the late 90s is when space agencies worldwide started developing small satellites, huh?
Yes, and the small satellite market is growing. ESA estimates that between 2009 and 2011, for example, 7 single payload launches could have been performed by Vega.
Other studies report that an estimated 5 to 7 satellites, small satellites, should be available every year between 2010 and 2015, all heavier than 250 kilos and therefore compatible with Vega. That means 1 ton, 1.5 tons into polar orbit. Yeah. Or in a low Earth orbit. Typical Vega missions of the future will be sun-synchronous orbit. Is that what you expect? Small satellites like tonight's with multiple passengers. Yeah. In our last film tonight, we'll continue our series of profiles of professions here at the Space Base. A look now at a launch site operator.
My name is Alexandre Massé. I'm an Arianespace engineer, age 32, and I'm electrical assistant for the Ariane 5 and Vega campaigns. I started my career with an experience as a test and validation engineer for the Ariane 5 flight program. I then integrated the operations and launch arrays division at Arianespace, and with a very extensive scope with the 3 launchers, Ariane 5, Soyuz and Vega, which need to be operated and maintained. I worked on several specialties and am now a deputy assistant at the digital and software section in charge of the control benches and electrical systems, flight controls and launcher measures. After the first successful launch of Vega, ESA entrusted us the operation of this launcher. Arianespace's work is now to provide maintenance and operations for the Vega launch system. Applying the same methods across Ariane and Vega is all the more easy that some of the software and electrical systems are identical. We have started optimizing the processes and we can leverage the experience acquired through Ariane 5. My team is constituted of specialty managers in guidance, navigation and control, as well as safeguard, pyrotechnics and sequencing. We perform functional operation control and operational controls with specialty managers and electrical specialists. We provide controls of the software and electric system, for instance, through nozzle control. And on Vega, these controls on the nozzles are performed on the 4 nozzles on the 4 stages. Here we are at the 4th level of Vega, where this box here has been installed to perform all of the verifications of interfaces between the launcher and the upper section. All of these controls are provided from the control center and allows us to verify before integration of the upper section. During a campaign, the electrical assistant manages operations of the electrical and software and pyrotechnic systems and assists the COEL, DDO, in all these operations. Between the COEL and the DDO, there is an exchange of status reports, red lights and green lights, which follow a certain number of rules of inhibition or acknowledgement, either automatic or manual. The operation performed by the electrical assistant with the DDO is therefore to verify that data exchanges are functioning properly. What's very interesting at Arianespace is that you can work on a great variety of jobs with teams from all over Europe for Ariane 5 and Vega, and with teams from Russia for the launches, the Soyuz launcher.
Interesting films give you an idea of some of the other jobs going on here at the space base, over 1,500 people in all. Proba-V separation due now in just under 4 minutes. While you were watching that film, we were picked up by our next downrange tracking station in Perth. The Australian station will see the second AVM firing, which is coming up in just about a minute. Also separation of Proba-V. There will be a final downrange tracking station, that's at Lucknow in India. The station will see the 5th and final ignition and extinction of AVM. That comes at 2 hours, 17 minutes into the mission. We won't be here, but this is to deorbit the vehicle. Now, why do we need to deorbit the vehicle?
Yes, today we are more sensitive to the space debris, and it's not anymore acceptable to leave things that are not used, as it was done in the 60s.
Yeah, it's a big question, space debris.
Yeah, very big. There was a conference about 3 weeks ago. And so we deorbit the AVM in order to leave space clean. Huh? And it happens with the 5th burn that we mentioned before. AVM, it's lowered down and into an orbit low enough to ensure within a few years a re-entry into the atmosphere where the stage will burn.
DDO has just called out, and you can see the beginning of the second AVM burn coming right on time at about 822 kilometers up. Our speed 7.4 kilometers per second. Why do we need the second burn?
So you've seen after the first burn, the launcher was in a ascent on an elliptical orbit to join the altitude of 820 kilometers. You can see it on the
upper left, yeah.
Yes, on the upper left, the path. Yeah. So now, during the ballistic phase, the initial speed was transformed in altitude, which grows up. Now, with the second burn, the launcher speed is speed up to the velocity of 7.5 kilometers in second in order to have a circular orbit at 820 kilometers into which we will release the satellite.
because we had our top speed, which was almost 7.9, I think more than 7.9 kilometers per second, and then we slowed down and we're speeding up again.
Yeah.
So that's the advantages of the reignitable upper